today I'm going to present my little research, which is under title A Morphological Study of Porous Silicon Layers for Photovoltaic Application. Index, we have Introduction, Experimental, Surface Morphological of Porous Silicon Layer, and Conclusion. Introduction. Porous silicon, a fascinating material formed by anodization of crystalline silicon, has captivated researchers and scientists for its unique properties and versatile applications. Its nanoporous structure, coupled with tunable optical and electrical properties, has opened up a world of possibilities in fields such as optoelectronics, photonics, sensing, and biomedicine. Understanding the morphology of porous silicon layers is crucial to harnessing its full potential. In this work, we delve into the intricate world of porous silicon layers and explore the significance of morphological studies in unlocking their exceptional properties. Experimental. Preparation of porous silicon sample. The porous silicon film were obtained by electrochemical etching, following a well-defined protocol. The cleaned silicon wafers were immersed in a Teflon cell containing 50 ml of etching electrolyte prepared by mixing hydrofluoric acid solution 40% and C2H5OH 98% in volume ratio. The ethanol solution was used to obtain a uniform porous layer and to minimize the formation of hydrogen bubbles on the surface, thereby homogenizing the porous layer. The silicon substrate is plated vertically as an anode against a circular hole, offering a surface area of 0.64 cm square in contact with the electrolyte. On the other hand, a circular gold grid was used as the cathode in our electrochemical reactions, as shown in figure. Around porous silicon layers with a diameter of 10 mm, we designed a anodizing bowl with a circular opening. Figure 1 shows the schematic diagram of the anodizing apparatus consisting of the anodizing tray. This anodizing cell is a stabilized power supply that delivers a constant current. It uses a metallic electrical contact on the backside of the silicon wafers, which is isolated from the HF ethanol solution by an HF inert ring. Thus, only the front side is exposed to the attack of the electrolyte. It is evident that the diameter of the O-ring controls the diameter of the resulting porous silicon patch. This remains valid when edge effects are not taken into account. To ensure the reproducibility of the morphology of the layers and to be able to control the porosity and thickness, the dissolution was carried out with a constant current flow between the two electrodes. Then, surface morphological of porous silicon layers. Scanning electron microscopy is known to be one of the most important techniques in studying the surface morphology of the film by direct two-dimensional surface imaging, as well as possible determination of the average particle size due to the sufficient electrical conductivity of the doped silicon. Scanning electron microscopy is a method of choice to visualize the structure of this porous material. The sample is observed directly without prior metallization. In the case of pores, it is essential to use a field effect SIM to have the necessary resolution. To image obtained with this technique illustrates the variety of structures that can be obtained. Figure 2. The choice of anodizing parameters can result in either straight channels or a more self-similar structure. Invariant structure, self-similar structure, skull invariant structure. The surface of the generated porous silicon layers may be seen to have a cluster of identically sized pores. This quantity was chosen to characterize the pore production phenomenon. Additionally, because the layer of P-type, an increase in current causes an increase in the size of the pores, which brings us to the entire etching condition that is familiar with electropolishing. See figure. The depth and lateral extent of the etching depend on the density of the anodizing current. In conclusion, porous silicon is a material with a wide variety of structures that can be obtained electrochemically. Its remarkable thermal and optical properties allow it to be used for the realization of many devices, despite a dangerous manufacturing process related to the handling of hydrofluoric acid. In this work, the study of pore morphology obtained of porous silicon films was investigated. The PSL films fabricated on P-type silicon 100 wafers. The possibilities of chemically modifying its surface by grafting molecules allow the development of new applications in the field of microenergy and molecular separation applications. Finally, it is anticipated that this investigation may open the way for other studies related to the promising development of porous silicon layers for photovoltaic applications. Thank you.